Hello everybody, today we will talk about solubility of substances, about solutions, and we will consider more detail the saturation and concentration of solutions. First of all, let's figure out what are saturated solutions and non-saturated solutions. So when we say saturated, it means, as you can see in the picture, there are a lot of particles of the dissolved substance that is called solute. In unsaturated solutions, the dissolved substance is in small quantities. It means that saturated solution consists of more number of particles. So a saturated solution is such a solution in which a maximum amount of a solute is dissolved. Like it cannot dissolve more. Let's say not solution but a solvent, if a solvent can still dissolve some more particles, some more solute, in this case we can say that this solution is non-saturated or unsaturated. However, if the maximum amount of a substance is dissolved and no more substance can be dissolved, in this case we consider the solution as a saturated solution. And now let's take an example. Imagine that this is a glass and it contains water. Let's imagine now that in this volume we can dissolve 10 grams of, let's take sugar. Let's imagine that this is a glass with water. We don't know which volume of water here is, but in this volume we can dissolve 10 grams of sugar. And now let's draw. So these both are particles of sugar. Let's imagine that these are 5 grams of sugar. So we dissolve here 5 grams of sugar. Certainly all 5 grams of sugar will be dissolved because this liquid actually can dissolve 10 grams of sugar. And we dissolved only 5 grams. So we can say that 5 grams of sugar will be easily dissolved here. So, and it still can dissolve 5 grams. You see now we are erasing these particles. It means that they are dissolved and we cannot see, because if you dissolve sugar in water, you cannot see it. It's dissolved and here you cannot actually see that there is some sugar or something. It seems uniform. Imagine, okay, already here we have 5 grams dissolved. And now let's dissolve 2 grams. We add 2 more grams of sugar into this glass of water. We already have 5 grams. 2 grams are added. It means that overall there will be 7 grams of sugar. It's still below that 10. So it will be dissolved, easily dissolved. So now we have 10 grams of sugar dissolved in our glass of water. Again, we erase the particles to show that they are dissolved. And let's add again. Let's suppose we add now 3 grams of sugar. So we have 7. We add 3. Okay, and overall 10 grams. In this time, we already have the maximum amount of sugar that can be dissolved here. So in this case, if you start stirring it, we stir it in order to dissolve sugar, right? So stirring will go heavily. It will be difficult to stir because there is much sugar now, but anyway you will be able to dissolve it. Okay, so we can maximum dissolve here 10 grams of sugar. 10 grams are dissolved. What then? Imagine now we keep adding sugar, more and more sugar. What will happen? Imagine that we have again 5 more grams of sugar here. Look, 10 grams are dissolved, the maximum amount. We add 5 more grams. It means that we overall add 15 grams, not 10 grams. But it cannot dissolve 15 grams. So what happens in this case? It simply will not dissolve. And 5 grams will remain in excess because we have 10 grams maximum that can be dissolved. We add 15 grams. It means 5 grams will remain in excess and they will just precipitate on the bottom of our glass. So 15 grams are added, 10 can be dissolved maximum, so 10 grams are dissolved. It means 5 grams of sugar will precipitate. So we can say that this solution is saturated. Saturated solution is such a solution which has already dissolved the maximum amount of a solute that can be dissolved here. In our case, maximum amount of sugar that could be dissolved was 10 grams, and this water, in our case solvent is water as an example, and it has already dissolved 10 grams, it cannot dissolve more. So this solution is saturated. Now, it should be mentioned that if the temperature increases, the solubility also increases. So if we increase temperature or pressure, solubility increases. Now, let's imagine that we are heating our solution. And if we heat, the temperature increases, and at a higher temperature, for example, we now can dissolve 15 grams of sugar, not 10. So the rest of 5 grams that precipitated will be also dissolved. So we erase the particles, it means that they are dissolved again. But after that, okay, we heat it. It is completely dissolved, but our solution cannot always remain hot. So our solution starts cooling down. At least it comes to the ambient temperature, and so temperature falls. When it returns to the ambient temperature, at ambient temperature we say that it can dissolve just 10 grams of sugar. But we dissolved 15 grams. What happens? At a higher temperature it can dissolve 15 grams, but it returns to the ambient temperature. Again, its capacity becomes 10 grams, dissolving the 10 grams of sugar. So the extra 5 grams that were dissolved, they start appear in our solution like crystals. So this extra 5 grams appear again in the form of crystals. Well, such a solution is called oversaturated because it can dissolve 10 grams, but we heated it and we made it dissolve 15 grams. So it dissolved more than it could dissolve at the ambient temperature. Such a solution is called oversaturated. That's why when temperature falls, the extra amount of the dissolved substance again recrystallizes. This process is called recrystallization. Crystals of dissolved substance appear. If we continue decreasing the temperature even lower than the ambient temperature, let's imagine that the temperature falls below. We put it into the ice bath and we keep cooling down. In this case, we can say that the dissolving capacity will be lower, it will fall, and now it can dissolve maybe less than 10 grams, okay? 9, 8, or maybe 10 grams, less than 7 grams, less than 10 grams. In this case, from this dissolved 10 grams, some odd amount of sugar will also recrystallize, and when we decrease the temperature a lot, we get more and more crystals of the dissolved substance. So I will draw them with different colors. Every time when we decrease the temperature, we get even more crystal. So the amount that cannot be dissolved at this temperature starts recrystallizing, and we get a lot of crystals of such a substance. So when a solution has dissolved the maximum amount of the solute that it can dissolve, and it cannot dissolve anymore, such a solution is called saturated solution. Okay, so let's now take another example. Let's imagine now that we have a solution. This time let's consider it in mass, not with volume but with mass. We take 10 grams of a solvent. In the previous case we took water. Here it can be water or any solvent, any liquid. We take a solvent. We have 10 grams of solvent. And let's imagine that the maximum amount of a solute that can be dissolved in this solvent is 8 grams. So we dissolve 8 grams of a solute in this solvent. In this case, we get a saturated solution. So our solution is saturated because we have already dissolved here the maximum amount of a solute that can be dissolved there. And it would take not 8 but 7 grams of a solute now. In this case, it's not saturated because it still can dissolve some more, like 1 gram. It can dissolve 8 grams, but we dissolve here just 7 grams. So this solution is non-saturated, but it is concentrated. The concentration is high. So let's figure out what concentration is. When a solution is concentrated, it means like a little bit amount is missing for making it saturated. If a solution is non-concentrated, or we call it also diluted, it means like we have more solvent and we have less solute, so we need to add a lot of solute in order to make it concentrated. If we need to add a little bit solute to make it saturated, it is concentrated, a concentrated solution. If we need much solute in order to make it saturated, this solution is not a concentrated solution, or we call it a diluted solution. Well, so it's not saturated but concentrated. Okay, now let's take another example. You see here we have 5 pictures, like 5 glasses with water, or let's say not water, just solvent. And each of these glasses, let's suppose that each of them contains 1 liter of a solvent. So 1 liter. And for example, in 1 liter of the solvent, we can maximum dissolve 5 grams of a solute. So in the first case, we see we have 5 grams of solute dissolved here. This solution will be saturated. This solution is saturated because it has already dissolved the maximum amount of a solute. In the second case, we have 4 grams of a solute dissolved here. In this case, even in all the other cases, like 2 grams, 1 gram, all of them are non-saturated solutions because we don't have maximum. We still can add some more solute, so we don't have the maximum amount of solute in them. So these solutions are not saturated. However, in the case of 4 grams, we see that we are missing just 1 gram. Yes, a little bit is missing, and we need to add a little bit of solute to make it saturated. In this case, we can say that this solution is concentrated. In the next 2 cases, we can say that these solutions are diluted. They are not concentrated because, look, we have only 2 grams or 1 gram, so in order to make it 5 grams, we need 3-4 grams. That's why we say that the first one is saturated, the other ones are non-saturated, but if we are talking about concentrations, we'll say the second one is concentrated, the third one is diluted, and the last one is very, very diluted. So here you can see the formula of how to calculate the solubility coefficient. So we get the mass of dissolved substance, I mean the maximum mass of the substance that can be dissolved. We divide it by the volume of solvent. We multiply it by 1000. Now I will explain it. Look, for example, we have a certain volume of solvent. And in this volume of a solvent, we can dissolve maximum m gram of a substance. So this maximum amount that can be dissolved is divided by the volume of solvent. It's better to take it in milliliters. And then we multiply it by 1000. Why? Because solubility coefficient shows the mass of a substance, the maximum mass of substance that can be dissolved in 1000 milliliters of a solvent. That's why we divide it by volume but then we multiply it by 1000 to find it in 1000 milliliters. Okay, and let's take an example to understand it better. For example, let's imagine that we have 5 liters of a solvent, and in these 5 liters of our solvent we can dissolve 25 grams of a solute. So solute is a dissolved substance in a solvent. Let's find the solubility constant. What will be the solubility constant? We take mass of a solute divided by the volume of solvent in milliliters and multiplied by 1000. So we have 5 liters of a solvent. Let's convert it into milliliters. So 5 liters will be 25 milliliters. No, sorry, 5,000 milliliters, not 25. 5 liters will be 5,000 milliliters. Well, we take now 25 grams, like the maximum amount of a solute, yes, M of a dissolved substance, 25, and divided by 5,000. So it will be 25 grams and 5,000 milliliters, and we multiply it by 1000. We multiply by 1000 in order to find how many grams of a solute can be dissolved in 1,000 milliliters of our solvent. So the answer here will be 5 grams per milliliter. So here we can conclude that in 1,000 milliliters of this solvent, so 1,000 milliliters means 1 liter. Yes, we have 5 grams, the maximum amount of a solute that can be dissolved. So this will be solubility constant. Okay, here now we can say that when we increase the temperature, as we mentioned before, solubility of solids and liquids increases. However, solubility of gases decreases. So if we dissolve liquids or solids, in this case we increase the temperature, they are dissolved better. But gases are opposite. With increasing temperature, their solubility decreases. Well, when we increase pressure, solubility of all the substances increases. All, both liquids and gases and solids, etc. So that's all for today. I hope it was clear for you all. If you have questions, ask me, contact me. You may write your questions in comments. I'll try to answer you all as soon as possible. Well, see you in the next videos. Bye.